Real-world C programs are typically made up of many different source code files. Even a very simple program like as the Hello World program that we started this course with way back in step 2 includes code from more than one file. Let's take a look at that again. Well, here is the Hello World program from back in step 2. Now you can see I've entered all my own code, just a few lines of code, into a single file, main.c. But that file imports code from another file that's provided with my C compiler. That's this line up here, #include, and the file it imports is called stdio.h. This tells the compiler to include, that is, to make available to my program, the contents of the named file. Now this file is one of the standard library files supplied with C compilers. The angle brackets tell the compiler to search for this file in the location that's reserved for the standard library files. And when the file is found, its contents are inserted just as though really you'd copied and pasted them. They're inserted at the point in your source file where this include statement is written. So a file with the extension .h is called a header file, and a header file typically contains definitions of functions and also of constants. And here I'm in CodeLight, and in fact I can see what's in this header file. I right click it and it's got an option, open include file, and you can see there are a whole load of different sorts of constants and functions declared in this file. So I'll go back to my little program. The header file doesn't contain the implementation of the functions, only their declarations. The implementations are generally contained in normal source code files that end with the extension .c. To include header files that are supplied as standard with your C compiler, you would normally use angle brackets like this, #include angle brackets stdio.h, and close the angle brackets. But to include header files from the current directory, that is, files that you've created within the current project, you would use double quotes like this. This is one of my header files, so I've #include, and then I've put the name of the file, mystring.h, between double quotes. Now, while you should always include header files that define the functions and constants that your programs need, you might be surprised to discover that sometimes you'll be able to use functions that are declared in header files even if you forget to include the appropriate header file in your project. And here's an example. Printf is defined in stdio.h, but if I comment that out and run the program again, well, the program runs, it compiles and runs. All that happens is that I'm shown this warning down here. It says implicit declaration of function printf. Now, the fact that I can use this file shows that it must have been compiled. Well, it has, because what happens is the C compiler often compiles source code files that contain the implementation of the functions that you're using, but if you don't include the header file that defines those functions, then the compiler may not have been able to check that all the data types used by the function calls in your program, that is, the types of data returned from functions or passed to functions as arguments, that those data types are correct. To understand why header files are important, you need to understand a bit about how your source code is turned into an executable, a runnable program. Now it turns out this is in essence a three-stage process. In the first stage, a tool called the preprocessor is run, and that processes your source code files, and it handles special preprocessor commands, those that begin with the hash character, such as #define to define constants, and #include to include header files. And then in stage 2, the compiler itself runs. The compiler takes the code, the preprocessed code, and it compiles it into an intermediate format called object code, and it saves this compiled code into a number of separate different files ready for stage 3. And this is the stage at which the linker runs. The linker is a tool that goes through all those pre-compiled object code files and it puts them all together into an executable file. The file that you want to run at the end. It's the file that the user will probably double-click and get the program to run on their operating system. Bear in mind that at stage 2 of this 3-stage process, that is, the compilation stage, the compiler processes each source code file separately. So you might have one file that contains a function called, well, as I've got in my project here, a function called readlin. But there might be, well, 9 other files, let's say, that call this readlin function. I've got one file here, main.c, but in a large project there could be many other files that call this readlin function. Now, since the compiler processes each source code file one by one, it can't verify that the implementation of readlin in one file, that is in the file as here where it's actually been written, it can't verify that that implementation matches all the function calls to readlin in all the possibly many other files that use it. So the file containing the readlin function and the files calling the readlin function are only put together in the final stage. That's by the linker. And by that time, if there are any problems, it's too late to fix them. But if you include a header file, here I've got my header file, and the header file defines exactly what types of arguments the readlin function takes and what data type, if any, it returns, then the compiler will be able to refer to this documentation in the header file. So when it compiles each of the C source code files, it's able to verify that all of them use exactly the same definition of the readlin function as specified in the header file. If any source code file doesn't use the correct definition, then the compiler is able to spot the problem and it will show you a warning message. So put simply, when you define functions in a header file, that file can be used by the compiler as a sort of a reference document. As each individual source code file is compiled, the compiler refers to the definitions in the header file to make sure that all the source code, the C files, agree on the types of data sent to and returned from the functions they use. So the declarations of functions in a header file help the compiler to find potential problems before they can become bugs.